If A is greater than B, B is greater than 0, and C is less than 0, which of the following statements must be true? We know that this is our premise. We're assuming this is true, and we need to evaluate each of the statements at a time, which in this case, they are also inequalities, all of them. One way to try and simplify statement 1 would be to get rid of the denominator b minus a. Okay, so in order to do so, we would multiply both sides of this inequality by b minus a as a factor. So we would have this. The effect of doing this, removing the denominator on both sides. But let's be mindful about property number 1. What is property number 1? What does this property have to say? It said that when you multiply both sides of an inequality by a positive factor, okay, you get rid of the factor, but the thing is, when the factor by which you multiply or divide both sides of an inequality is negative, the inequality symbol must be reversed. So, this inequality symbol needs to change to less than. Why? Because of the sign of b minus a. If a is greater than b, b minus a is negative. You can check that very easily. So, this results in this following inequality. A minus c is less than b minus c. Okay, we can adapt c on both sides of this inequality in order to get rid of this term. And of course, the inequality symbol would remain. When you add a common term on both sides of an inequality, nothing happens with the inequality symbol, and you would get this as a result. A is less than B. This is a direct contradiction of our premise. This is false, never true. Let's try statements 2 and 3 one at a time. Statement 2. Okay, we notice common factor A on both sides of the inequality. We will simplify it by doing a division. Both sides of the inequality will be divided by A. So it will result on this. Cancel A on both sides. Since A is a positive number, okay, the inequality symbol will remain, and you will have B is greater than C, which actually coincides with this inequality. Since B is positive and C is negative, B is always greater than C. So this is always true. Then we need to analyze number 3. We have a common factor on the spot here. We can get rid of it by dividing both sides by B, right? B over A divided by B, B over C divided by B. The inequality symbol will remain because B is positive. So we get rid of B, and we have 1 over A is greater than 1 over C. 1 over A represents the inverse or reciprocal of a positive number A. So this must be positive as well. And 1 over C represents the reciprocal or inverse of negative number C. So 1 over C must be negative as well, because taking the reciprocal of a real number doesn't change its sign. So we have a positive number greater than a negative number. This is always true, no matter what the numbers are. So we need to pick our answer choice. That would be 2 and 3. Statements 2 and 3 must be true.